Hello Primary 7 and welcome to week 3 of online learning with maths. We are looking at pie charts this week. We have been looking at pictographs and bar charts and line graphs last week, and this week we're going to look at pie charts, which is our last type of chart for just now. And then the second part of this lesson is going to be giving you the opportunity to take some of the data that you filled in on the forum last week or you kept track of yourself at home, and you're going to have a go at creating your own graphs with that data. Okay, I'll give you more explanation of that at the end of this video. Let's get started. Our first part is going to be listening and working along. You won't really need anything for this. You might want a pencil if you want to jot down some answers, but we're just going to have a look at pie charts together. You can have just a read through this slide by yourself. The key bit on here is that we're going to be looking at fractions to describe a pie chart, but nobody panic. It is very, very simple to use fractions to describe a pie chart, and I'm going to show you exactly how to do it. Okay, here are some pie charts. A pie chart is a circle that is divided into sections, and it gets its name because it looks like a pie that has been cut into slices. I like the picture on the left. It has been created after a vote of people's most popular fruit pies, and then the person who has created it has taken images of those pies to make it into a chart. So the part that was biggest, lots of people liked strawberry and rhubarb. That's quite a big section. Not so many people like the cherry section, so that is smaller. On the right hand side, you've got your methods of travelling to school, and this is what pie charts normally look like. So it's a circle with different coloured segments, and the bigger the segment, the more people have voted for that one. So the cars in the red have got 9 votes. It's the biggest segment, and 9 people have said that they travel to school that way. In contrast, the train has only got 1 vote, so it's the smallest segment. And it's really useful because it's a quick and easy way to see where the most of something is or the least of something is and what's in the middle. This is an interesting fact that I never knew. It was invented more than 200 years ago by a Scottish engineer and economist called William Playfair. And some of you might know about the Playfair Library in Edinburgh, which is part of Edinburgh University, and that's named after him. He developed lots of methods to represent data, including line graphs and bar charts, or bar graphs. So we've already come across some of the things that he invented. And he invented them to show economic data, so to show data about the state of the economy, what people are spending money on, that sort of thing. Pie charts allow us to see different pieces of related information and to compare them to each other. Okay, the whole circle represents the whole one of something, and it's then split into parts, and they can come with different names. They're sometimes called sectors or segments or wedges, which represent different options within that whole thing. Okay, so it sounds quite complicated, but actually if you look at it, it makes it really obvious. So in this picture here, got a little meme for you. There once was a whole pie, and it was a lemon pie. And in yellow is the pie that I have not yet eaten. And where you can see the segment of missing pie, that is the pie that I have eaten. And you can see that there's a little key at the side to show you that that's what the different segments mean. So this is just a bit of fun, but hopefully you can see how it was a whole, and what it's showing now is still what's happened to the whole pie, but some of it has been eaten and some of it has not. If we look back to last week's chocolate selection box, this is what it looks like if I make it into a pie chart. Now this doesn't have lots of different colours, it's got different shades of blue, and you can see that in this case there isn't a key at the side, but the labels are written around the outside. And I just wanted you to see that it's not always shown exactly the same way. And a bit like we were saying last week, graphs like this and charts like this are a bit of a puzzle. You have to look at them and work out what it is that they're showing you. Okay, so on here you can see the different proportion of each chocolate in the selection box. Now, if you remember from last week, actually there wasn't a huge difference. The smallest number had 4 of those chocolates in, and that was things like the Twirl and the Dairy Milk and the Crunchie, much to my disappointment. And the one that had the most was the fudge. And you can see that on that pie chart, but because the numbers are all quite close together, they're only between 4 and 6, it's a little harder to see than when you've got numbers which are very different to each other. So let's get thinking about these pie charts in a wee bit more detail and having a go at some things yourself along with me. Here is a pie chart, and I want you to have a think about some of these questions that are coming up. There's 4 questions altogether. I'm going to put all of the questions up, and then I want you to pause the video and have a little think about what you can see. So the first question, what do you think the whole of this pie chart is about? How many people's votes make up the whole circle? What are the different segments representing? Representing just means showing. And why are the segments different sizes? Pause the video and just have a think. You might want to almost say it aloud to yourself so that you form the idea in your head clearly. Okay, so this pie chart is about pets, and it's pets in our class. So we know that it's a class of children who have been asked. Well, I'm making a bit of an assumption there. It might not be children, it might be an adult class. But pets in our class. How many people's votes make up the whole circle? We can see that the total is 28. So 28 people have been asked. What are the different segments representing? Well, the different segments are showing the different pets that the people have. And why are the segments different sizes? They're different sizes because more people have dogs than have cats, and more people have cats than have hamsters or fish. So the bigger the segment, the more people have voted for that. Just before we go on to look at fractions and pie charts, I want to just remind you about how fractions work, because we haven't done them for a while. So probably most of you will remember having done something similar to the sheet on the left, where you've got various different shapes and they are split into equal parts, and some of the parts are shaded in and some of them aren't. And the challenge is to say what fraction of the shape is shaded. So we're going to start off with the light blue one up in the top corner, this one here. And we're going to see that there are 3 parts that are shaded out of 4 parts altogether. And we know that we can say that as 3/4. The parts that are shaded go on the top, they're the numerator, and the parts altogether, the parts that it's split into, go on the bottom. And there are 4 parts altogether, 4 equal parts. Let's have a look at this next one in, the pinky purple one. This is a circle, so this is most similar to our pie charts. And we can see that there are 2, 3, 4, 5, 6, 7, 8 parts in total. So that goes on the bottom. And we can see that 5 of them are shaded. So 5/8 is that one. Let's have a look at this yellow one. There are 2 parts in total, and one of them is shaded. This is probably the first fraction that we learnt, it's a half. Let's have a look at this bright green. It doesn't look like traditional quarters, but we can see that there are 4 parts altogether and 2 of them are shaded. So we've got 2/4, and some of us might know that 2/4 is the same as a half. We're going to skip the middle one and have a quick look at this orangey one over here. We can see that there are 6 parts altogether, and there are 5 of them shaded in. So when we move on to our pie charts just now, I just want you to keep this at the front of your mind, that the number on the bottom, the denominator, is the total number of parts, and the number on the top, the numerator, is how many you have for the thing that you're looking at. In this case, we're looking at how many of those parts have been shaded. Okay, let's have a look at them with pie charts. Now, we can also use fractions to describe pie charts, and that's what I'm going to show you how to do just now. Fractions are, remember, if we're splitting a shape or a number into equal parts, it's saying how many of those do we have. So, what fraction of people have dogs as pets? Remember, we're thinking about things like halves, quarters, thirds, fifths, tenths here. What fraction of people have dogs as pets? Hopefully some of us have spotted that half of the people have dogs as pets. Now, if you look where my red line is going, you can see that half of that circle, imagine if I continued that all the way around, so I had cut it into two pieces. If I cut that circle into two equal pieces, half of it has been taken up by votes for dogs. So 1 out of 2 pieces has been taken up by votes for dogs. What fraction of people have cats as pets? What fraction of people have cats as pets? Here's the cat segment. Okay, hopefully you can see that blue line. Now this time it's not half, but if I continued those lines to split the whole of the pie up into equal pieces, I would end up with 4 equal pieces. So I would end up with quarters. And one of those quarters is taken up by votes for cats. So 1/4 of the people have votes for cats. Now, have voted, sorry, for cats. You might also have spotted through the numbers that 7 is a quarter of 28 and that 14 is a half of 28. So either the picture or the numbers could have helped you to come up with those fractions. The next one is a wee bit trickier, and this is something that is probably new to most people. What fraction of people have fish as pets? Now, here's the fish section. It's not hugely obvious what fraction that is. It's not obviously a fourth or a half. We might guess that maybe, well, it's a bit like a half of a quarter, so maybe it's like an eighth, but it's not quite exactly. In these cases, the way that you think about it is you look at your total, which in this case is 28, and you imagine that your circle is cut up into 28 equal pieces. So one for every person who has voted in this case. And that is the number that goes on the bottom. That's the denominator. You might remember that from fractions before. The bottom number is called the denominator. And in this case, it would be 28. So we're imagining, and I'm not going to draw it because there's no way I could do it accurately. We're imagining that this circle is cut up into 28 individual pieces. And out of those 28 pieces, it's then easy to see that 3 of them would be coloured in, because out of 28 people, that's how many people voted for fish or had said they had fish as their pets. So our fraction would be written like this. It would be written as 3 out of, and I sometimes find it helpful to almost think of that line as saying out of, 3 out of 28. So 3 people out of 28 people have fish as pets, and that's how you would write it as a fraction. What about this one then? What fraction of people have hamsters as pets? Use the same method and the numbers at the side to think about where your total would be and where the number of individuals who voted for hamsters would go. Use your hamster segment. Now, I'm thinking that most people have probably thought the red answer there, the 4 out of 28. 4 people out of 28 people voted for hamsters. A few of you, if you're really enthusiastic and enjoy working with fractions and have done quite a lot of it, might have simplified that fraction on the left, the red fraction, into the green fraction. Now I'm very, very quickly going to explain how that has happened, But if you do not understand this bit, do not worry, because we have not looked at this in any detail at all in class yet. Okay, and it's something that we will come back to when we're looking at fractions in more detail. You might have spotted that 4 and 28 are both in the 4 times table. They're both multiples of 4. And so if I divide them both by 4, I end up with 1/7. So I do 4 divided by 4, so 4 shared equally between 4 would be 1 each, they get 1. And 28 shared equally between 4, it would be 7 for each. Okay. And that's all it means to simplify fractions. It's to look and see if there's any number that you can use to divide both the top and the bottom of the fraction. And if there is, then you do that, and it gives you a simpler version of the fraction, but it means the same thing. If that makes sense to you, then that is fantastic. If it doesn't, do not worry about it. You don't need to know it for pie charts. I just wanted to point it out for people who were maybe curious. Let's move on. You can also use fractions to work out how many people have chosen an option if we only know the total number of people taking part. So on this one, I've got rid of the individual votes and you can only see the total. How many people said they had dogs? Now, you might remember this from the last slide, but see if you can find a way that you could work it out using your fractions and your knowledge of the total. Pause the video and have a think. Okay, I'm going to pop this up for you to have a look at. We can see that half of the people said they had dogs, and that's half of 28 people altogether. And we know that if we're finding half of something, then we're splitting it in two, we're dividing it in 2 equal parts. And we can therefore work out that 28 divided by 2 is 14. Half of 28 is 14. So if we know that half of the people have voted for dogs, because that's what it shows us on the graph, and we know that the total was 28, then to find out how many people voted for dogs, we just need to find half of that total. How about the same thing for cats? Pause the video and have a think. Now there's a couple of ways that people might have worked this out. They might have said, well, 1/4 of 28 is how many people voted for cats. And 1/4 is the whole thing divided into 4. And 28 divided by 4 is 7. Or you might have thought, well, I already know what a half is because I just worked it out. And 1/4 is just a half of a half. It's a half cut in half again. So if a half is 14, then 1/4 must be 14 cut in half again. 14 divided by 2. And that would give us 7. So there's 2 different ways there that you could work it out. Now, there are ways that you can use fractions to work out the numbers for fish and hamsters, but that is very much more complicated than we need to be doing just now. So we're going to move on. Let's have a look at this one together. I just want you to pause the video and look at the pie chart and come up with as many bits of information as you possibly can. You might want to even think of some questions that you could ask somebody else about this pie chart. Okay, we're going to have a look at how we use the pie chart writing in fractions. How many people have been counted in total in this vote, first of all? Pause the video and count them up. Well done, there were 30. 30 people have been asked in total. Of those 30 people, how many people walk to school? That's a quick one. 8. 8 out of 30. The blue segment we can see from the key is the walking segment. Here is the blue saying that walking colour is this blue and it is 8 out of 30. Okay. If we're writing that as a fraction, which number would go on the top and which would go on the bottom? Which would be the numerator, the number on the top, and which would be the denominator, the number on the bottom? Hopefully you've remembered that we could do it as 8 out of 30. And again, I've just shown you there what it would look like if you simplified it. This time, they can both be divided by 2. So 8 divided by 2 would give you 4, and 30 divided by 2 would give you 15. So you could write it as 8 out of 30, or you could write it in its simplified version, 4 out of 15. Remember these green sections? We don't need to worry about them just now. If we got the bit on the left, sorry, the red section, then you are grand. Okay. What fraction of people get the bus to school? Bus is this green colour here. If we find it on the chart, here we go. 4 out of 30 get the bus to school. And if we're having a go at simplifying, we can divide them both by 2, the top and the bottom, and we get 2 out of 15, or 2/15. What fraction of people get to school without using something with an engine? That's a wee bit more thinking required there. You might need to pause for a second. Okay, things that don't have engines: walking and cycling, unless you've got an electric bike, but we'll go with them not having electric bikes for here. So we need to look at our walking and our cycling. Together, that's 13. And it's 13 out of 30. Now, there is not a number that divides into 13 and 30. 13 is a prime number, which you might remember from a little while back. So we just leave it like that. We can't simplify it. What fraction of people do not walk to school? Have a think about the words. What fraction of people do not walk to school? Well, if 8 people do walk to school, and we know that there's 30 people altogether, then we're going to need to do 30 take away 8 to find our answer. And that would give us 22 out of 30. Or if we're simplifying it and dividing by 2, we get 11 out of 15. Okay, the last bit that I want to touch on today is looking at pie charts and percentages. Now, percentages is not something that we have done a lot of work on in school yet. And again, we're going to come back to it again. I just want to give you an idea of how they work with pie charts. Percentages are things that we come across quite a lot in life, especially in things like the sales, if it's got 10% off. And it's something that we think about quite a lot with things like batteries as well. So it's not totally unfamiliar to us, even if it looks a wee bit scary. So sometimes, as well as showing the pie chart or the fractions, it's useful to include the percentages of the whole that each section represents. This is the key part. When we're thinking about percentage, 100% is the whole of the circle. So 100%, if you've got 100%, it means that's everything in the circle. So in this chart, 100% is 28, because 28 is the whole or the total number of people who completed the survey. So for example, if 100% of people who were asked had a dog, it would mean they all had dogs. What do you think the pie chart would look like in that case? If you said that it would all just be one circle with dog written in it, then you're right, because there wouldn't have been any cats or hamsters or fish, because everybody would have said that they had a dog and not the other animals. And if we're thinking back to the pie before, where we had the pie I've eaten and pie I haven't eaten yet, if I had eaten 100% of the pie, that would have been totally empty. It would have been all gone, because 100% of it has eaten the whole of it. Now, percentages, I think, are sometimes useful to think about as our batteries, because it's something that we see a lot and is very, very familiar to us. Just looking really quickly at those batteries, I bet you could tell me roughly how much battery you had left. Yeah, so the one at the top left is totally full, and the one in the bottom by my face is totally empty. Your phone is about to give out on you. Okay. This one is 100% full. It's got all of it. The whole of it is full and charged. This next one is about 3/4 full. If we split that battery section into 4 equal parts, there's the part at the top, there's the next one, there's the next one, and the bottom, excuse my dodgy writing with the little cursor. You can see that we have 3/4 of our battery left, and 3/4 when it's written as percent is written as 75%, because if there were 100 altogether, there would be 75 that we would have. This next one, I think you'll be able to spot quite quickly. We have about a half left, and a half, if it's written as percent, is written as 50%. 50 out of 100 left. This one, well, we're looking again probably at our quarters, but now we have only got 1/4 left. And when that's written as a percentage, it's written as 25%, because 25 out of 100 pieces would still be left in our battery. Now this next one down here, I'm not going to draw lines on for, but I would guess if it was this, if this one over here is about 25, about 1/4, then probably this one here is roughly 15 out of 100, 15% left. And this last one, 0%, nothing is left at all, and our battery is out of charge. So if we're looking back at this one, which pet do half of the respondents own? Well, we know half of them own a dog. And if we can see that it's half on the pie chart, and we know that 14 is half of 28, are we able to write it as a percentage? Can you remember what half looked like as a percentage? It was written as 50%. 50%. So half, or 50%, of the people who did the survey have a dog. This last one just now asks what percentage of people own a cat. And if you can think back to the batteries, or it might be a fact that you know already, we can see that 1/4 of people in the survey owned a cat, and we know that 1/4 is the same as 25%. If it's not something that you know yet, then don't worry, because there will be lots more practice on percentages later in the year. Okay. Have a look at this pie chart. This is our last one together before you have a go by yourself. I'm going to give you some questions. What does this pie chart show, and how do you know? Hopefully you have spotted that this pie chart shows people's favourite type of movie, because that's what the title says. And that's why titles are so important in your graphs and charts, and they're very easy to forget. So always make sure that you have a title. How many people took part in the vote? Pause and have a count. Okay, hopefully you have managed to add those numbers up, and you have spotted that there are 20 people who have taken part in the vote. 6 add 1, add 4, add 4, add 5 is going to give you 20. And what was the favourite type of movie? Easy to see at a glance, this one. The favourite type of movie was a romance movie. Okay, let's have a look at these ones with the percentages. If you add up the percentages, and I'm just going to show you quickly which ones they are in the brackets here. If you add up the percentages, what do they get to? And why do you think that is? Pause the video and check. Hopefully you have got, if you add these all up, you get to 100%. The way that I did it is I put the 5% and the 25% together first to make 30. Then I took the 30% to make 60. And I know here 20 add 20 is 40. And 60 add 40 will be 100. So when I add them all up, I get 100. And the reason that that is because I've totaled up all of the votes. And remember that 100% shows me the whole, or the total, of the votes. Okay, it's time for you to have a go by yourself, and the independent parts for this are quite short and should be fairly straightforward for you. The first is a wee craft, and I have put a video into the class materials folder to show you how to make that, as it was a bit easier than doing it in a PowerPoint. It should only take you about 10 minutes and it allows you to play around with pie charts and have a go at creating some of your own in your house. The other activity is an independent worksheet, and I'm going to show you that just now. This is the top of the independent worksheet. At the bottom there are some questions. What I just want to draw your attention to before you start is that on these pie charts there are small markers. Now, if you have a look at them, you should be able to spot that they are equally spaced out around the outsides of the circle, and they are there to help you imagine that these are in smaller segments. So imagining, and this is not going to be a straight line, but imagining that these circles are split like this into 16 segments, because that is how many people have been asked here. 16 children. So when you come to answering the questions, use those lines to help you work out how many are in each of these complete segments. So here, dodgy line there guys, sorry. Here is a complete segment, and the wee lines here are showing you each individual person's vote. If you had drawn them in, this would be one person's vote. Draw this one in, this would be another person's vote. Here's a third person's and a fourth person's. Here's your third person, your fourth person, and just make sure to remember to count that last part there as well, fifth person. So you can use them to work out there that 5 people have voted for comedy. If you want some extra practice, I have put up some TJ pages. They are quite challenging, so I would probably only go on to those ones if you're really up for a challenge. But again, they use these markers to help you break down the pie charts, so make sure you look at those carefully. Right, off you go guys and enjoy.